My name is Chiadi Ndumele. I'm the Center Director for the Strategically Focused Research Network at Johns Hopkins, or SFRN, that's funded by the American Heart Association. Our SFRN project is really focused on understanding the relationship of obesity with the development of metabolic risk factors and what that means for heart disease risk and prevention. We know that individuals with obesity have a higher likelihood of developing diabetes and other metabolic risk factors like high blood pressure and abnormal cholesterol. What we don't understand is why some individuals with obesity have a greater likelihood of developing those, while some individuals seem to be relatively protected against the development of diabetes and these metabolic risk factors.
In our first research project, we investigated adipokines, proteins secreted by fat tissue, and their relationship with metabolic health in middle-aged adults. Our findings revealed that adipokines are not only linked to metabolic health status at baseline, but also serve as predictors for the progression to a less healthy metabolic state, such as developing metabolic syndrome and diabetes over time. Conversely, having more favorable levels of these adipokines was associated with regressing back to a metabolically healthier state. We also used proteomics to identify several proteins specifically associated with heart failure risk among individuals with obesity. These proteins seem to account for the majority of obesity-related heart failure risk and enhanced risk prediction for heart failure in individuals living with obesity. We showed that these proteins were also linked to abnormalities of heart structure and function before the development of clinical heart failure.
When the metabolic risk factors develop in obesity, we know there's an increased risk of heart disease, but the pathways that lead to that risk are not so well understood, and we want to better define those to inform new targets for prevention. We know that weight loss is so important to this conversation, but the implications of weight loss for the heart, even for individuals at different levels of metabolic risk, is not fully understood.
We compared individuals who underwent weight loss surgery with individuals with the same level of obesity who didn't undergo surgery. At baseline, we observed that among individuals with similar levels of obesity, those with worse metabolic health had higher levels of heart damage based on markers in the blood. After about a year of follow-up, participants in the weight loss surgery group had about an 8-fold higher likelihood of transitioning from having detectable heart damage to having undetectable heart damage. We also observed that participants who lost more weight had a higher likelihood of no longer having detectable heart damage over follow-up. Finally, the reduction in heart damage after weight loss surgery was seen regardless of the level of metabolic health participants had at baseline. Our findings highlight the beneficial impact of weight loss in improving heart health for all persons with obesity, even for those who appear to have relatively better metabolic health.
One of the really exciting things about this SFRN was the synergy between our population/clinical projects and our basic science project. And we really had complementary work going on between the two projects, both focusing on adipokines and understanding the pathways leading to metabolic risk factors and heart disease development.
The main goal of our project is to understand how adipokine influence the heart function under the diabetic condition. What we found is the beneficial effect of adipokine actually requires one of the protein involved in nutrient sensing as well as energy production. Importantly, this protein is significantly reduced at the diabetic heart. Considering heart is one of the organs which cannot take a break or slow down, this is quite problematic. At this point, what we are trying to do is what exactly causing the decrease of this protein, and then whether there is any way to prevent that using the pharmacological tools. Understanding the molecular target, we will be able to come up with a better therapeutic strategy.
This SFRN has led to some really important insights. We now have a better understanding of the factors that are related to why some people with obesity develop metabolic risk factors and diabetes while some individuals don't. And it's shown a central role of adipokines in that process, which could suggest new targets for preventing the development of metabolic risk factors and diabetes in individuals with obesity. We also have an enhanced understanding of how these adipokines actually lead to the development of heart dysfunction through this really exciting basic science work. Additionally, we've used proteomics to be able to uncover new pathways by which obesity and diabetes lead to the development of heart failure. And this could uncover a whole slate of new targets that could help us understand new ways to prevent the development of heart failure. And finally, we understand that obesity causes silent myocardial injury, even in individuals who don't have much in the way of metabolic risk factors, but that weight loss is going to be beneficial for reducing that heart injury in all individuals with excess weight.